All right, so today is the last lesson that we're going to do on trig. It's actually the last lesson we're going to do for this school year. I know. So tomorrow we will review the trig stuff. Friday we're going to quiz. That gives us 3 days for exam reviews next week. And then the final. Any questions on scheduling issues? Scheduling issues? I got a new pair of shoes. All right, so there are 3 trig functions that are less popular than the 3 you are very familiar with. So we have sine, cosine, tangent, and then we have the reciprocal of those. Okay? All right, so if you want to find the cosecant,
what do you want?
It's the same as the sine, but flipped. So see how sine is opposite over hypotenuse? The cosecant is hypotenuse over opposite.
That's it.
You just flip it. Okay? Secant, we shorten with SEC. So if you want the secant of an angle, it's the cosine flipped. So this would be hypotenuse over adjacent.
What?
You just take the cosine and you flip it. So cotangent, you would just flip the ratio. So now it's adjacent over opposite.
Hold on.
Okay? So when you go from like tangent to cotangent, you don't change the angle at all. The angles stay the same, but the ratio gets flipped. All right, so for our first example, they're giving us a trig ratio. We have to find the other 5. So you want to start by drawing a right triangle. So if this is angle B,
How do you draw a right triangle?
this just a triangle with a right angle. Label one of the angles B. Now, this is opposite over hypotenuse, so we know 2 sides of the right triangle already. When you are missing a side of a right triangle, do you guys remember how you can find it?
Yeah, there's a family.
A squared plus B squared equals C squared. So I'm going to do x squared plus 5 squared equals 8 squared. It's the Pythagorean theorem.
Isn't there families?
There are families, but this is not one of them.
3, 4, and 5.
3, 4, and 5 is a family, but there's no family that includes
12,
5 and 8.
And 14 too.
No, it's like I think it's 5, 12, 13. Yeah.
Okay.
All right, so we're going to subtract 25 from each side. So x squared equals 39. So x is going to equal square root 39. So this side is square root 39. Okay, any questions on how we found the missing side of the right triangle?
No.
You just use the information from the trig ratio. So we had opposite, we had hypotenuse. Now I want to write the other ones. So you could rewrite, I like to write all 6 of them together. So I'm going to rewrite the sine. Then I'm going to write the cosine, the tangent, the cosecant.
What's the cosine of B? Dang!
The secant,
Square root of 39 over 8.
and then the cotangent. Okay, let's do them in pairs. So if the sine of B is 5 over 8, what's the cosecant? 8 over 5. You just flip it.
CSC.
Okay. Now let's go to cosine and secant. From cosine would be what?
39 over 8.
Square root 39 over 8. Now, there's a problem, and I'm going to do the work off to the side. When I flip that,
You can have that.
yeah, we can't leave the square root 39 in the denominator, so what am I going to do? Multiply by what?
No, why do you have to do that?
Do you guys remember this? It's rationalizing the denominator.
8 root 39 over 39.
So yeah, your answer for the secant would be 8 square root 39 over 39. 8 and 39 don't go into one another, so you're good.
Yeah,
All right, and then tangent. Oops, I lost my B. Tangent of B is opposite over adjacent. So 5 over square root 39.
39
Now, before I rationalize that, I'm going to flip it.
do it.
So the radical's fine where it is when you flip it, but I still need to rewrite this guy. So how would I do that?
39 over 39 like you did.
Yeah, multiply top and bottom by square root 39 over square root 39.
5 red, 39 over 39.
Very good. Now, see how I went back to the radical in the bottom, though, before I flipped it? Because if you rationalize it, then flip it again, you'll end up with a bunch of crazy stuff. So if it's in the denominator and you know you're going to flip it before you rationalize. It'll just save you a step. Okay? Now, these next ones we're going to need a calculator for. So remember, these new 3 trig functions are the reciprocal of the original 3 trig functions.
1 over sine.
So this is 1 over...
Sine 13.
Incorrect.
4.4.
Incorrect.
Yes, it is. No, it's not.
Secant does not go with sine.
Oh, it's cosine.
You'd think they do because they both start with S's, but it actually like
1
flip-flops.
over cosine 13.
Very good.
Equals 1.02.
We're rounding to 3 decimal points in the
1.026.
in this section. Very good. Everyone practice typing that in. Depending on what calculator you have to type it in a little differently. Like the one I was using, I had to do 1 divide by 13 cosine equal sign. But some of them you can do 1 divided by parentheses and then type it in
This
equal.
one's a point something.
We're going to let everyone take a minute to double check number 2.
What about CS?
All right, are we ready for number 3? So yeah, this will be 1 over 10. Bless you. 78.
$0.212.
2.12.
And then the last one, this goes with sine. So 1 over sine 20 degrees.
That's 0.213
Yeah.
if you're rounding.
Oh, okay. Sorry. What comes after the 2?
A 5.
Oh, well,
So
sure.
it's a 3 now.
Sorry about that.
Backside.
Hold on. I don't have no. What is this one?
Backside 2.7.
2.924.
It won't let me divide by
So there are special right triangles. You, I'm sure, learned about these in geometry, so these shouldn't be a super shocker for you.
Why are they special?
Because
It's just a right triangle.
they are. So the first special right triangle is a 45, 45, 90 triangle. And these are special because the side lengths are all related in a special way. For example, if you have a 45, 45, 90, it's actually an isosceles right triangle, so those two sides are the same. And then this one is always that same number times square root 2.
I do not miss this.
Okay? This other one is a 30, 60, 90. Now 30 is always across from the smallest side. So it's easiest to see which side is smallest. Go across, that's your 30. The other one's your 60, and then the 90 is pretty easy. Now, across from the 30
That's an X.
is an X. Perfect.
60 is 2X.
It's the other way around. The hypotenuse is 2x. And then across from the 60 is x square root 3.
X square root.
Doesn't make any sense.
Yes.
Yeah,
These are just special relationships that, I mean, you could do the Pythagorean theorem to derive these. I would probably just try to memorize them. So the next one says, if a triangle contains any of the special angles, the special triangles, you can find the exact solution for your trig functions. So instead of telling me like 0.0157, some really weird decimal, you would actually say like square root 2 over 5. Like you could find the actual, with the radical, exact answer. You don't need to round. That's what that means. Any questions? So in number 5, we have a right angle and a 30-degree angle. So the other one's got to be 60. So this is a 30, 60, 90.
Don't do it.
So look up at 30, 60, 90. The hypotenuse is 2 times some number x. What would x be in this case? 6. They multiply it by 2 to make it 12, right? We're looking for the shortest side across from the 30.
We're finding the sides.
6 square root 3.
We're missing an x. Sorry, you should have an x right there.
What the heck is going on?
You should have an x right there. It's just I forgot to put an x, Ryan. Calm down.
6
Okay. Hold on. In a 30, 60, 90 triangle, across from the 30-degree angle is a number.
X.
That number times 2 is your hypotenuse.
So that's 6 and the other one is 6 root 3.
Yeah, we're not even looking for this side. It would be
So
6
12
root 3.
equals 2x.
But the only thing we're looking for is this. Yes. If you need to write an equation, that was actually correct. We know that the side that's the hypotenuse in a 30, 60, 90 triangle is it plays the role of 2x. So if you need to write it out to find x, go for it. A lot of people can do it in their head. Okay?
Definitely not. That's a 30, 60, 90 too.
All right. This one, number 6.
You can't go by looks. It's geometry.
Now,
45 in this test, you're going to be the same. Dumb.
okay, so this number 6 is not a special triangle. If the 10 was the hypotenuse, it'd be a 30, 60, 90, but it's not. So how can I find theta if I just know 2 side lengths?
Do the sine. Or no, cosine. I mean tangent.
Yeah, so we can do tangent theta equals opposite over adjacent. This is what we did yesterday. So you would have to take
Tangent of x equals 2.
this guy of both sides, right? So the inverse tangent of 2 will give you the value for theta.
63.4
Very good. And that's a degree measure, so put the degree symbol.
for degrees.
All right. Is number 7 a special right triangle? Yes. And in a 45, 45, 90, I have x and x for the legs. What's the hypotenuse?
X rad 2.
Yeah. So here I can't really do this one in my head. So I'm going to have to set this equal to x square root 2. So divide both sides by square root 2.
Divide.
Yeah, you gotta get the x1.
So x is going to equal 6 over square root 2. But we can't leave it like that.
6 rad 2 over 2, which is, snap.
So it's actually 6
rad 2.
rad 2 over 2.
Well, yeah.
Square root 4, yep. So 3 square root 2.
3 rad 2. That's what
How
it
do you leave like the red 2 over the red 2?
I'm just rationalizing the denominator. I can't leave square root 2 in the denominator for my final answer.
Where did you get 6 from?
I told you.
So when I multiply the denominator, I get square root 4. And the square root of 4 is just the number 2. And then these are just regular numbers, so you can divide them. 6 divided by 2 is 3.
Bingo bongo.
All right, number 8. Special or not so special?
Not special.
Not
at
so
all.
special. So now I just have to use my basic trig functions. What should I do?
Opposite over adjacent is TOA tan.
So tan 34 degrees
34.
43.
43. You know I'm slightly dyslexic. It's nothing new.
43 degrees.
9 over x.
9 divided by tangent of 43.
So yeah, 9 divided by tangent 43.
X equals 9.7.
Anyone agree with 9.7?
So when do we
Yes.
I get it. Right.
9.65. But you go to.
So when do we use the CSC
Yeah,
in the stack?
For these types of problems, I probably wouldn't use those. She's talking about the new ones because they're not really buttons on the calculator anyway. So it would just make things more confusing. You could, but this is
You're confusing.
this is not really connected to what we did on the front. It's sort of a separate. It's like two little lessons. Okay.
Did you get the worksheet?
We have 2 more
Oh
examples.
my goodness.
So number 9 is a 30, 60, 90. If you were trying to find the hypotenuse, you are correct. It would be a 10, but we're trying to find the other side.
It's 8.6.
5 square root
8.7.
3.
5 square root 3.
What? How'd you get that?
Because it's a 30, 60, 90 triangle. So if this is 5, the shortest side is 5,
Oh, x equals 5.
then 2 times 5, and then 5 square root 3. Yep. Yeah, 5 is playing the role of x in this one. Now, your answer isn't incorrect, but the direction said if we could find the exact answer to use it. So it means if it is a right triangle, special right triangle, use that first.
Yeah.
All right. Number 10.
Holy crap.
What the nugget? This one?
A
You
squared
gotta
plus B
do.
squared equals C
This is basic Algebra 1 Pythagorean theorem.
For real?
Yep. A squared plus B squared equals C squared.
So 4 plus 64 equals.
Yep, other way.
No, it's not.
64 is the hypotenuse side.
Oh my God.
So 4 plus y squared equals 64.
square
Minus
root
4.
70
Other way.
Squared equals 60.
equals 60.
Square root 60. And then do a tree.
7.7.
Bless you.
Unless you want to do a tree.
Oh, we gotta do a tree.
We gotta do a tree. It says to give an exact answer when possible.
2 rad 15.
Yeah. So 4 goes into this 15 times, and then 2 and 2.
Y equals 2 rad 15.
All right. You have finished your final Algebra 2 Advanced lesson. How do you feel?
I'm feeling freaking.
Hallelujah.
Woo! All right, here comes the homework, and then we will review tomorrow.